Hey folks, how's it going? This is Mr. Murray coming to you with a little video on angle bisectors, okay? So in this video, I'm going to talk about what is an angle bisector, some of the problems that we often encounter when we work with angle bisectors, and how to go through some of those, kind of in a sense where I try and we try together, and then I have problems for you to try as well, okay? So when we think of an angle bisector, what is it? So first of all, it has something that has to do with an angle, right? In other words, the space between two rays or line segments or lines technically. In this case, we can see it's the space between rays. And then we know that, well, bi means two and sector means sections. And we know they're cut into two equal sections, right? Each one being half of the total. So for example, if this entire angle is 144, then these each have to be two equal halves of 144. If this one is the whole angle is 45, right? We need each of these to be two equal halves of 45, okay? So bisector, two sections, sections are equal, okay? So when we think about bisectors, there's three kind of common problems we sometimes deal with. First, and I put letters on these just so that I could talk about them in a more informed and maybe mathematically precise way, okay? So if I have a bisected angle ABC, all right, with DB as the bisector, and I know one of the two, okay? And maybe it's not ADB, maybe it's more, to be clear here, ABD, okay? So in other words, if I know the whole angle and I know one of the halves of the angles, can I find the other half of the angle? Okay. Also, let's say that I know the angle is bisected. I don't know what it is, but I know it's bisected. And I know one of the halves. Can I find the other half? Okay. A lot of the times we will see these come up with numbers, but the more interesting and challenging ones are problem type 3. And 3 is just kind of like a catch-all really for questions like 1 and 2, these types. But when there's like X or even Y or a letter that you actually have to solve for, so it makes the problem a little bit more interesting than working with numbers and halves. Okay? So here's some problems where I'm going to do them, and maybe I'll offer you opportunities to chime in. But then this is mostly going to be done by me. And then in a moment, later on in the video, there's going to be problems for you to try as well. Okay? So I have this. I have a triangle, an angle ABC. I know it's bisected. I know that ABD equals 86 degrees. The measurement, I need to find CBD and ABC. Okay? So to start, whenever I'm given this information, I want to make a few notes. So first of all, I know that ABD is 86 degrees. I also happen to know, though, that I don't know the other half, but I know because this is bisected that these have to be equal to each other, okay? And specifically because it's bisected, right? If these are going to be two equal parts, then CBD needs to be the same as 86, or rather as ABD, and meaning it's got to have a measurement of 86. And now that we know the two parts that make up the angle, we can actually get the whole, okay? So here I have 172 degrees. Now, people are going to say, Mr. Murray, this figure is not drawn to scale. This is like, what the heck is going on? So that's one thing. I don't often draw a lot of figures to scale because when I'm drawing a little figure to do a problem, I'm not so concerned what it looks like as I'm concerned that you can apply some of the ideas we've been talking about, all right? You know, figures aren't always going to be drawn to scale, though sometimes they're drawn to a little bit better scale than this, right? Because we can see these halves, right, are supposedly almost 90 degrees. We know they're not that much. But again, I would not expect figures to be drawn to scale ever, at least when I'm not, at least when they're my problems, okay? Okay, so now I'm going to go ahead and move down to this next problem. So I know that DEF is bisected, okay? And I know that MDEG is 56 degrees. And I know that FEG is 3x plus 5. And I'm going to presume degrees. I need to find x, the measurement of FEG, and the measurement of DEF, okay? So let's start with this. First of all, we know this is being bisected, right? So what do we know about these two angles that I'm drawing in red now? We know they are equal to one another, okay? So what that means is that 3x plus 5, because these are congruent, their measurements are equal, okay? So remember, congruent means that these figures are, geometrically equal, right? And to be congruent means that they're the same distance apart, the rays that make up the angle, and same distance apart means the measurements are equal, okay? So let's say I'm going to solve this for x. So I'm going to subtract 5. I'm going to divide by 3, and I'm going to get 17, okay? I already know that FEG, technically, it's not as interesting as a problem because this needs to be 56 for them to be equal, and this needs to be 112 degrees, okay? So please go ahead and make sure you understood where I got this from, all these numbers, okay? Again, the 56 that we're given, solving for x because they're equal, and then just taking these and adding them together. Please make sure you understood where that came from. I am going to go ahead and move down in a moment, but again, anything you need to rewind, go ahead and do that before I move on. All right, now I've got GHI is bisected, we know that, and M of GHK is 5x minus 2, and M of IHK is 4x plus 1. I need to find x, GHK, IHK, and GHI, all of those measurements. So what do I know? Again, this is bisected, so what do you know about the angles? Okay, right, the measurements are the same. How do we express that the measurements are the same? Using math and equations. What's it going to look like? So we have 5x minus 2 is equal to 4x plus 1. So let's solve. So there's two ways to do this. I could add the 2, subtract the 4x, or I could subtract the 5x and subtract the 1. I'm going to add because I like to add more. So I've got 5x equals 4x plus 3. Then I'll minus my 4x. X is equal to 3. And we can check our work. 15 minus 2 is 13. 12, right, plus 1 is 13. Perfect. So we have 3, and we've actually now, by doing that, plugged them in, figured it out. We know that each is 13, okay, giving us a total of 26 degrees. Okay, so please make sure you understand where I got that from. I am going to add one more problem in here, but if you need to rewind, go ahead, and then in a moment I will move on. All right, I know it says stop here, but I do want to add one more problem because there's one that I haven't really hit on. So let's say that I have an angle here, okay? And let's say the angle is bisected. Now, that's not a perfect bisector, so I'll erase it. Okay, I'll take credit for that. I'll make this bisector hopefully a little bit better on my second try. Here we go. Okay, it's a little bit better. So this is bisected, right? Let's say I know the whole thing is, I don't know, 3x plus 5. Okay? 3x plus 5. Now, on top of that, I know that this, okay, because this is 3x plus 5, okay, so that means that this has to be, I don't know, maybe let's call this x plus 6, okay? What is x in this situation? So let me get my letters in here. So I've got A, I've got B, I've got C, I've got D. So I'm basically given that ABC, the angle, is bisected. Okay? And I have my measurements. How am I going to solve this? So think about it. If I have ABD and DBC, what do I know about this angle here and this angle here? They're equal, right? Because this is bisected. Now, what do I know about these two parts? What do they have to add up to? They have to add up to the whole thing, which is 3x plus 5. So I have x plus 6 plus x plus 6 equals 3x plus 5. Okay? And when I combine like terms, I subtract my 2x, I subtract my 5, I can solve for x in this kind of problem too. So here's a problem where you know one piece, you know the whole thing. Can you solve for a variable then? When you have to remember to double the angle and think of those things there as well. So it's another type of problem. It's not a different type, but it's a different use of variables. Okay, so again, please make sure you understood this problem that I did here. Rewind if necessary, and then in a moment I'll move on for ones to you to do. All right, so these are more of you try problems. So I'll give you the information, okay? And what I'm going to ask you to do is, one, try to solve the problem. Okay, pause the video before. So you pause the video, try to solve the problem, and then I'll unpause and show you how to do it. So what we have here is we have the angle ABC. We know it is bisected, and you know that ABD is 28.5. Can you find CBD and ABC? Okay, so take a moment, pause the video, try to find out those two pieces of information. Then when you're ready, unpause, and you'll see if you're right. All right, so here's what we know. I know that ABD is 28.5 degrees, and I need to find CBD. But look, this is bisected, so CBD needs to be 28.5, and ABC, well look, if these are both 28.5, I want to know ABC. I just take 28.5, I add 28.5. And what I get is 57 degrees. Okay? So please make sure you understand that. Rewind if needed, and then in a couple seconds I will move on. All right, you try problem 2. Given that DEF and what I should say is DGF is bisected, okay? I know that measurement DGE is 39. I know that, so this is DGE. I know that FGGE is 5x minus 6. I need to find x. I need to find FGE. And I need to find DGF. Okay? So please take a moment, pause the video, try to set this up and find the needed information. And then when you're ready, unpause, and I'll show you how to solve it. All right, so here we go. So here's what I know. I know that DGE is 39 degrees. Okay? I know that FGE is 5x minus 6. So here we go. Well, what do we know? 39 equals 5x minus 6. So I add 45 equals 5x. So x is equal to 9. Okay. Well, I know FGE without having to plug it in. That's 39 degrees. And adding them together, because each one of these is the same, that gives me a total of 78 degrees. Okay. So this one, again, hopefully relatively straightforward. Please make sure you understood how I do this, and then in a moment I'll move on. All right, now given GHI is bisected and GHK is 3x plus 37 and IHK is negative 2x plus 12, find x, GHK, IHK, and GHI. If we can technically have to put a symbol there. Okay. So again, please take a moment, pause the video, try to solve and figure out these 4 blank spaces. And then when you're ready, unpause and I'll show you how to solve it. All right, here we go. So I'm just going to extend this a little bit. So I have GHK. So let's fill in what I know. 3x plus 37, negative 2x plus 12. Okay, now what do we know about these two? They are equal. So 3x plus 37 equals negative 2x plus 12. So let's solve for x. So here I'm going to, and 2 ways to do it. I prefer to add 2x on both sides. So 5x plus 37 equals 12. Now I need to subtract the 37. So 5x equals 12 minus 37, which is negative 25. So x is equal to negative 5. A little bit more difficult because now you actually have to plug it back in to solve. So to check our work, if I plug in negative 5, I get negative 15 plus 37 is negative 22. If I plug in positive 22, negative 15 plus that. If I plug in here, negative 5 times 2 is 10, plus 12 is 22. So again, negative 15 plus 37, 22, 10 plus 12, 22. So GHK is 22, IHK is 22, so therefore GHI, 44 degrees. Okay. All right, and so in general, I just want to note, anytime you have a measurement of an angle, like see, I even missed it here, you should be talking about degrees because this means measurement, okay? Okay, so one more problem that I want to do. I want to throw this one in here. It's going to be similar to the previous one when I added it in. So here's my angle, and let's say that my angle is bisected. This is the whole angle. So what I'm saying is the whole angle. Let's give these letters. R, J, M. I don't know. K. All right. RJMK. So RJM is bisected by JK. Okay. RJM, the whole angle RJM, okay, has a measurement of negative 5x plus 30. Okay? Negative 5x plus 30. Okay? Here, what I have is 2x plus 60. Okay? So I have negative 5x plus 30 for the whole angle. All right? And then I have 2x plus 60 for the half angle. Okay? So what we're going to do is we're going to take a minute. And what we're going to do is we're going to try to solve this one. Let me just make sure I got all my numbers right here. This looks good. And this looks okay. Okay. So go ahead and try to solve this one. Solve for x. I need to know x. I need to know what's RJM measurement. I need to know what's RJK and what is MJK. Okay, so take a second. Please pause the video and try to solve this. Then in a moment we will move on, or rather I will show you how to solve before we move on to closing words. So please pause, try to solve, then when you're ready, unpause, and I'll show you how to solve. All right, here we go. So what do we know here? So we know that if this is 2x plus 60, what is this? This is also 2x plus 60. So adding these together, we get 4x plus 120 equals negative 5x plus 30. Okay, so by doing that, I get 9x plus 120 equals 30. Subtract 120, I get 9x equals negative 90. So x is equal to, if I divide by 9, It's equal to negative 10, okay? And so if this is negative 10, well, this is negative 20 plus 60, so this is 40 degrees. This is 40 degrees, and this then would be 80 degrees. And I didn't plug in because, look, I could, negative 20 plus, okay? But if this is 40, this has to be 40. And if these are 40, this has to be 80. And I could even try it here. So this is negative 40 plus 120 is 80. Negative 5 times 10 is 50 plus 30 is 80. So it works here as well, okay? So we have negative 10, 40, 40, and 80. Okay, so I hope you found this video to be informational and kind of help you get a sense of how we work with bisectors, what they are and how we solve problems with them. This is just meant to be a crash course or like even a refresher with some examples. All right, so again, keep up the questions, right? Keep staying persistent, and remember, as always, you can do it. Okay, again, thanks for watching. Have a wonderful day, and don't forget to love math.